In this video, we will explore how the total TB18001 generator generates electricity. We will break down the key steps in the process and the factors that affect its performance. The core components involved in generating electricity are the stator and rotor. The stator is the stationary part, while the rotor spins inside the stator, creating a magnetic field, which is key to electricity generation. Now, let's talk about the diodes and resistors. In a brushless generator like the Total TB18001, diodes are used to convert the AC current generated in the rotor into DC current. This is essential because the rotor generates AC, but the generator needs a steady DC supply to create a constant magnetic field. The resistors are part of the rotating rectifier system and help control the flow of current within the system. They work to limit the amount of current in certain parts of the circuit, preventing overheating and ensuring the components operate within safe limits.
Now I'll explain how the generator works. When the engine starts, the piston moves, which rotates the generator's shaft. This rotation generates mechanical energy, which will eventually convert into electricity. How the magnet field is created and how the current is generated. There is no current generated, but as the magnet starts to rotate, the strongest part of the magnetic field gets closer and closer to the coil. The coil experiences a changing intensity of the magnetic field. This will cause more and more electrons to be pushed forward up into its maximum intensity. Then the magnet starts to move away from the coil, so the magnetic field begins to decrease, and so does the current of electrons, until it reaches zero again. And now the opposite end of the magnet begins to get closer to the coil, and this pulls electrons in the opposite direction. This again reaches maximum point and then decreases back to zero. And so, if we were to plot this current on a chart, we would get a sine wave with a current flowing in the positive and the negative region. This setup gives us a single phase AC supply, but we have all this empty space between the coils, which seems to be a bit of a waste. So what can we do with all the space? Well, we can add more coils to create more phases and provide even more power. If we place another coil 120 degrees rotation from the first phase, this will give us a second phase. Why, do you ask? Because the coil is in a different angle, so it will experience the change in intensity of the magnet field at a different time. The current is therefore going to flow forward and backward at a different time. This gives us a sine wave, which occurs at a different time.
The carburetor helps mix fuel and air probably to keep the engine running at a steady speed, but it does not do the job of controlling the speed by itself. The mechanical governor is the part that actually adjusts the engine throttle to make sure the speed stays constant, even if there are changes in the load or speed. Since the generator does not have an AVR, which is an automatic voltage regulator, the generator depends on the engine to keep the voltage and frequency stable. If the engine speed changes too much, the output will not be steady. It's important to note that no system is 100% efficient. In this generator, there will be some losses due to mechanical friction, like the bearings and rotor, and electrical losses, such as heat generation in the diodes and resistors. These losses slightly reduce the overall efficiency of the generator, meaning not all of the fuel's energy is converted into electricity. As you have seen, electricity generation in this type of generator is heavily reliant on the speed of the motor. The more the speed, the more stable the voltage and frequency. Thanks for watching.